One of the most intriguing aspects of astronomical events is the possibility of a supernova. Betelgeuse can be found in the well-known shoulder of the Orion constellation. Betelgeuse is a massive red star, close to the conclusion of its life cycle. Interestingly, in 2019, one of the sky's brightest stars began to dim. Being clearly visible to the naked eye, its fading over several months drew attention from both professional and amateur astronomers. Its brightness diminished to such an extent that many observers questioned whether the star was dying. Scientists studying giant stars turned their telescopes toward it and were astonished by the evidence of significant fading. Betelgeuse is believed to be close to becoming a supernova, signaling the end of its life. But when and why? Will there be a massive explosion of the star? And if so, will it have devastating effects on Earth? Betelgeuse, a glowing ruby star, lies on the right shoulder of Orion the Hunter. Despite its other name, Alpha Orionis, it is the second most brilliant star in its constellation, shadowed only by the supergiant Rigel. It continues to fascinate astronomers due to its peculiar name and variable behavior. Alpha stars typically shine the brightest in their constellations, though the brightness of Rigel surpasses Betelgeuse. Still, Betelgeuse is distinctive due to its massive size. Also known as Alpha Orionis, it is a well-known star, part of the 10th most prominent constellation in the night sky, and the 7th brightest star visible from most of North America and Europe. The Arabic name for Betelgeuse refers to the giant's armpit, a nod to its position in the constellation. Betelgeuse loses about 1 solar mass every 10,000 years. It ejects material uniformly in all directions, resulting in a surrounding nebula. This nebula is about 30 astronomical units in diameter, 30 times the distance between the Earth and the Sun, and is larger than the star itself. At its core, under immense pressure, Betelgeuse's hydrogen atoms fuse into helium. This process releases heat and light due to its enormous gravity. As the hydrogen depletes, the star begins fusing helium and carbon. Eventually, after helium is exhausted, heavier elements like neon and iron are formed. Iron fusion, however, releases no energy, causing the star to collapse under gravity and explode in one of the universe's most powerful events, a supernova. Stars, depending on their age and evolutionary stage, emit light in different wavelengths, from the bright blue of new stars to the deep red of older ones. The ancient astronomer Ptolemy described Betelgeuse as curiously ruddy. However, ancient Chinese astronomers recorded it as yellow in color, implying that it might once have been a large yellow supergiant. Stars like Betelgeuse burn through hydrogen rapidly, bringing their lives to an early end, often within just 10 million years. There's no doubt Betelgeuse is nearing the end of its existence, while our Sun, by comparison, still has over 5 billion years to go. The nearing death of Betelgeuse suggests it could explode into a supernova at any time, though exactly when remains unknown. Betelgeuse undergoes 2 brightening and 1 dimming cycle every 5 years, each lasting about 100 days. It is believed that the expansion and contraction of its outer shell during these cycles affects its diameter and average temperature. As a result of its unpredictable behavior, Betelgeuse became the focus of intense observation in 2019 and 2020, when its brightness diminished dramatically, only to recover briefly. Several astronomers hypothesized that this behavior may indicate that the star is nearing the end of its life. In-depth research on Betelgeuse dates back to the 1st century BC, yet the cause of its recent dimming remains a complete mystery. Reports suggest Betelgeuse is moving at 30 km/s through the interstellar medium after being ejected from the Orion, OB1 group. A shock arc stretches out from Orion's belt, more than 4 light-years from the source. Measuring the distance to red supergiants like Betelgeuse is a difficult task in astronomy, and numerous factors make it challenging to determine its precise diameter. As a pulsating star, Betelgeuse changes over time. This phenomenon, along with limb darkening, where light is emitted unevenly across the star's disk, causes its visual signal to dim and shift in color. The circumstellar envelope, material expelled from the star, also absorbs and emits light. impacting how bright we perceive the star to be. This variability makes consistent observations of Betelgeuse extremely difficult, and its actual size remains uncertain. According to the wavelength and diameter used, measurements can vary, depending on the method, by as much as 35%. This is due to the wavelength used to measure them in the electromagnetic spectrum. In July 2009, the European Southern Observatory published photos taken with a VLT interferometer. These images, based on its base telescope, showed a massive gas plume up to 30 astronomical units in size, one of the atmospheres from the star. Multiple records of mass ejections from this star were documented. This ejection was comparable to Betelgeuse and proportional to the angular distance, 6 at most, between the Sun and Neptune. Around this distance, other ejections have also been discovered. This phenomenon may offer hints about Betelgeuse and the mystery of the widespread mass loss in the final phases of massive stars. Such mass loss could be the determining factor in their eventual demise. The complex dynamics of Betelgeuse's prolonged atmosphere remain a mystery, as does the precise process by which red supergiants eject this material. These stars are essential for the galactic matter cycle, and the continued advancement of interferometry techniques has deepened appreciation for this area of astronomy. Astronomers are making progress towards solving the mystery. In 2019, researchers using telescopes like the Hubble Space Telescope discovered that Betelgeuse had thrown off a significant portion of its observable surface, resulting in a substantial surface mass ejection, SME. Compared to the Sun's coronal mass ejections, Betelgeuse's event was 1,000 times more intense, ejecting material roughly 400 billion times larger than a typical solar coronal event. This explains why Betelgeuse suffered a rapid decrease in luminosity in October 2019. By mid-February 2020, it had lost much of its brightness, dropping from magnitude 0.5 to 1.7. By February 17th, Betelgeuse's brightness had stabilized. On February 5, it appeared the star had stopped dimming altogether. Nevertheless, the most recent visual fades were unrelated to any impending core collapse, due to the absence of significant changes in infrared readings. On February 24, 2020, no such changes were observed. Let us know in the comments what you think. Click the like button if you enjoyed the video, and subscribe to avoid missing out on more content like this. Eventually, Betelgeuse will explode in a supernova, one of the most remarkable celestial events in history. Despite being 640 light-years away, the explosion will be so bright that it could outshine the full moon in our night sky, and even be visible during the day for weeks or months. According to estimates, the supernova will produce more energy in a few seconds than our sun will generate in its entire 10 billion-year lifespan. The light from the explosion will eventually reach Earth, appearing as a brilliant point in the sky unlike anything we've ever seen. But don't worry, despite its power, we are completely protected. Betelgeuse is far enough away that the blast won't harm Earth or its environment. However, this explosion will offer an unprecedented scientific opportunity. Years later, Betelgeuse has returned to its prior levels of brightness, though inconsistently. Scientists continue to monitor the dimming cycles closely using instruments like the James Webb Space Telescope, the ground-based Hubble Space Telescope, and interferometers such as ALMA and VLT. They are observing changes in convective cell brightness, surface patterns, and persistent mass loss events, signs of stellar instability. One common hypothesis is that the great dimming of Betelgeuse was caused by a massive cloud of dust formed during one of these eruptions. This cloud temporarily blocked the star's light from our perspective. Astronomers stand to learn a great deal from Betelgeuse, especially about the life cycles of massive stars approaching supernova. This knowledge could help us understand similar events in other galaxies and contribute to our understanding of the universe's chemical enrichment, how elements such as iron and gold are created and distributed throughout space. Betelgeuse is essentially a ticking cosmic time bomb. It may explode within the next year, or in 100,000 years. But when it does, it will provide an unmatched scientific experiment and a cosmic light show, a true treasure trove for modern astronomy.